Okay, so in this video, we're going to look at how to divide fractions using Polypad and use these questions to develop the division algorithm. So we're going to start with two questions here that are whole numbers divided by unit fractions. And so we're going to use our sort of definition of division where we're asking ourselves how many pieces of size 1/4 fit into this piece that is of length 1. So 1 divided by 1/4. And for these questions, I'm going to actually, once we define the question, I'm going to take the actual fraction size out and just sort of concentrate on the fact that we're asking how many pieces of this size fit into the bigger piece, or into the piece that's 1. And so we can do that relatively easy here and see that you can fit 4 of those pieces in the one whole unit. And so that's relatively straightforward. We're going to leave it at that for now and come back to these questions as we to look at how it fits into the division algorithm once we've got the answers for all these questions. So we do the same thing here. So we're asking ourselves how many pieces of the size 1/5 fit into a piece the size of 2. So we want to see how many pieces this size will fit into here, and we can slide that along and see that 10 pieces fit in. And so we have an answer of 10. And again, we're only focusing on the answer just now. And so now that we have, I've done a couple of questions where we're taking a whole number divided by a unit fraction. Let's take a look at a slightly different set of examples. So now let's take a look at a fraction divided by a unit fraction. So let's take a look at this one here. We have 1/2 divided by 1/5. So how many pieces of this size fit into this piece here? So again, I'm going to take the designation off and just remind ourselves we want to know how many pieces of this size fit into here. And so we can see that it's 2 and a bit. It's 3 is too much, so it's 2 and a bit. We need another little piece here. I'm going to go ahead and grab a piece here, and we're going to use our splitting technique to see if we can find another piece that will fit into that spot. And we see as we split, we have this piece, which is 1/10 of the original whole. And again, I'm going to turn this off because that 1/10 can be a little deceiving because it's really not 1/10. This piece here is 1/2 of the original piece that we're dividing into. That it's 1/2 of the 1/5. And so we can see that this is 2 and 1/2. And more specifically, we can write that as 5 halves. 5 halves of the original piece fit into there. And so that's our answer. So let's try to do this with the this is actually not that different of a question. It's like the original question times 3, really, if you will. But we're not going to look at it like that. We're going to look at it like a fresh question. This is 3 halves divided by 1/5. So again, we're asking how many pieces of this size will fit into this whole piece here. And just as before, I'm going to take off the fractions so that we can just sort of see this as it is. And we're going to take a look here, and we can see that we fit 7 full pieces in and another little bit. 8 pieces is too many, and this looks like, and as you would expect because they're similar fractions, it's kind of the same piece as before that fits in here. It's that extra little half of a piece there. And so we can write this as instead of 7 and 1/2 fit in, we can say that 15 halves fit in. And so our answer here is 15 halves. So let's look at another set of examples. So in this case, we're going to take now a whole number. Instead of dividing by a unit fraction, we're going to take a whole number divided by some non-unit fraction. In this first question, we're asking 1 divided by 2/3. How many of these pieces the size of 2/3 will fit into this whole piece here? And as before, we're going to take the designation off here just so that we can see we want pieces of this size. Now, in this case, you can see that it's exactly one more half piece that fits in here, half of the original piece. And again, you might be fooled to think that that is a third if you left that on there, but that's a third of the whole. But we're talking about how much of this piece compared to the piece that we're dividing by here. And so that's why we say this is 1/2 of the original piece that we're dividing by. So in this case, our answer is 1 1/2, or 3 halves. So now we're going to take a look at 2 divided by 3/4. And so here's our 2 and here's our 3/4. So in the same way we've done before, we're dividing the 2 by this 3/1/4, this whole piece. And so when we do that, I'm going to get rid of the fraction designation so I can just sort of see the size of the piece here. And so we can see that, there's 2 of the whole pieces that fits in there. And if we go some more, you can see that it's not a full piece. This would be a full piece here, and so it's a little bit less than a full piece here. But the way it works out, we can actually see that it's 2 full pieces, and this is 2/3 of another full piece here. It works out just evenly. So it's 2 2/3, or more specifically, that's equal to 8/3. Okay, so now let's take a look at a unit fraction divided by a whole number. So we're going to think of this slightly differently than the previous ones, where we've said how many pieces the size of this fit into here. Instead, we're going to say, since we're dividing by a whole number, we can actually just say 1/5 divided by 2. That is, if we divide this 1/5 by 2, how big are the pieces? So we're going to do this slightly differently. We don't need this whole piece here. We just need to be able to divide this piece into 2 equal sized pieces. And so we're going to use the split feature here and do that until we get and see that that piece can get divided into 2 equal sized pieces. In this case, those are each 1/10. And so in this case, when we divide 1/5 into 2 equal sized pieces, those pieces are 1/10 in size. So we're using that second sort of way to describe division. And in the same way, we're asking ourselves in this question, 1/2 divided by 4, we're asking ourselves, if we divide 1/2 into 4 equal sized pieces, how big are those pieces? So let's do the same thing that we did here. We're going to split this until we see we can take 1/2 and split it into 4 equal sized pieces. We can see that happens when it's 1/8. And so one of those pieces would be 1/8. And so 1/2 divided by 4 is equal to 1/8. So in the end, we want to take a look at our fraction algorithm, and let's summarize this with the fraction algorithm in our minds here. So here are our 8 questions, and what I've done is I've actually put in what we normally would do for the fraction algorithm. So for example, the standard rule for the fraction algorithm is take the original question, invert the second fraction and multiply. So invert 1/4 and multiply by the inverted portion. So multiply by 4, invert 1/5, that's 5, multiply by 5 instead. Invert 1/5, that's 5, multiply by 5 instead. Same thing here. Invert 2/3 and multiply by the inverse, that's 3/2, invert 3/4, and so on. So I've written that down here. And with the answers that we got, and we can see that we get the answers that we did get earlier in this video. But the question now becomes, where does this actually come from? And I guess this is really where the magic or the witchcraft happens. And so let's take a look at individually where that might come from. Let's go back at our questions here. So we want to be able to see that this is equal to 1 times 4. And you can see that pretty readily here. You know, when we have one piece, it divides evenly 4 times in there, and you can see the 1 times 4 show up there. For this one, however, what we want to see from our algorithm is 2 times 5. And that's not necessarily as obvious to see. And so here we have to sort of think about, we're going to be thinking about the results of these division questions slightly differently now. So instead, we've got to sort of see where the meaning of this number is, that first number and the second number. And the way that we're going to frame this is we're going to say, okay, well, if we had 2 of the original piece, here's the original piece right here. And if we had 2 of the original piece instead. So we're going to use this first number as a proportionality of the original piece, twice the original piece. And the question is, how many times will twice that original piece fit into our answer? So, and we can actually see that it fits in exactly 5 times. And so that's where we're going to go with these questions. We're going to take that first number, and that first number is sort of a proportionality number for our original piece. Twice the original piece fits in 5 times to the original piece, the number that we're dividing into, not the one that we're dividing by. So let's see how that works with the other examples. This is what we're left with in our second set. So what we want to develop is 1/2 times 5, which equals 5/2. And so if we use the same idea, this first number is now a proportionality of the first bit, the number that we're dividing into 1/2. So 1/2 of this piece, we're asking how many of those fit in here. And you can actually see that here's 1/2 of that piece, and you can see it fits in 5 times. So that, again, that first number is a proportionality of the number we're dividing by, the original number we're dividing by, 1/5. So 1/2 of the 1/5, there it is. How many of those fit into here? Let's see if we can use the same reasoning on this one here. So in this case, we know what we want this to work out to. We want it to be 3/2 times 5 to equal 15/2. So this 3/2 now is 3/2 of the original piece that we divided by. So here's the original piece, and here's 3/2 of the original piece we're dividing by here. How many of those fit in? And you can actually see that you get 5 of those 3/2 pieces fit into our original number that we're dividing into. And so there's where the 3/2 times 5 comes from. Does this work out in the next one when we take a whole number and divide by a fraction? Well, let's see. So we have 1 divided by 2/3. We want that to somehow turn into the multiplication question, 1 times 3/2. to get our answer. And so the question, if we frame it in the same way, we're asking ourselves, well, if how many of the original piece fit the original the number we're dividing into, how many of those fit into the original piece of 1? And you can actually see that one whole piece and another half, or 3 halves of that original piece, fit in. And this one is relatively straightforward. In fact, usually when you take a whole number 1 divided by any fraction, it's relatively easy to see. But let's see that same thing in the next question. So let's get rid of these designations here, because now we're trying to figure out where the 2 times 4/3 comes from. And so again, we are using that 2 as the proportional value of our original piece that we divided into. So twice 3/4. So where's twice 3/4? So there's twice 3/4 here. So we're now asking how many of these fit into our original 2. So you can actually see that one whole one fits in. And then how many more of this whole one? Well, this is actually this piece right here. This piece, you can see, is 1/3 of this piece. And so this twice of our original 3/4 piece fits in 1 1/3 times, or 4/3 times. Does this work when we do 1/5 divided by 2 and 1/5 divided by 4? So here's what we want. We want this to somehow become 1/5 times 1/2. We know that equals 1/10. We know that's the right answer. Let's go back to what we originally had here. So we originally had the question 1/5 divided by 2. So let's put that 2 back in there. So there's our original question. So now if we do the same thing, this first number is a proportionality of the first piece. So 1/5 of the first piece, 1/5 of 2. So to show 1/5 of 2, that's actually 2/5. Let's split this into fifths so we can actually physically see that. There it is right there. And we want to know how many of these, how much of this, like how many of these, this piece, this whole piece here. Now again, I'm going to take the fractions off. So this is now 1/5 of 2. And we want to know how many of these fit into 1/5. And you can actually see that only 1/2 of that fits into there. And there's your 1/2 right there. 1/5 of the original piece we were dividing into fits halfway into the original piece that we were dividing. Let's take a look at the last one. So we want this last one to turn out to be 1/2 times 1/4. And let's put our original piece back in here. So this was 1/2 divided by 4. And so when we do this, we are looking for taking that original 4 and dividing it into 1/2 of that. So we want to know this piece here. Let me take this fractions off. How many of these fit into here, this 1/2? And to take a look at that, where we can see that it's not a whole one, it's only a part of that fits in there. We're going to start to split these, and we can see that 1/4 of this piece is what it takes to fit into the original 1/2, and there's our 1/2 times 1/4 to get 1/8. So that really confirms what the algorithm tells us, that we can actually, instead of dividing two fractions, or a whole number and a fraction, or a fraction and a whole number, we can turn that into a multiplication question by considering the proportionality of the 1/4 or the 1/5 or whatever by this first number, and then how many of those fit into the original 1, 2, 1/2, or whatever it happens to be to get that second number. And then we take the product of those, and that's our answer. That's where that comes from. And let's just see if this technique works with just any old fraction divided by any old fraction. So let's try this now with a fraction divided by any fraction and see if this technique works. Now we're going to do it in the opposite way now. We're going to use our algorithm to get the answer and then see if our technique gets us that answer. So in this case, we're going to be doing 3/2 times what the algorithm tells us to do is multiply by 5/2. And so that gives us 15/4. So let's see if, in fact, we get 15/4 when we visually do this division. So we're asking ourselves, how many of these pieces here, right here, fit into 3/2? This is our 3/2 here. And again, to get rid of the confusion, we're going to get rid of the fraction here so that we're just seeing how many of these pieces. And we can see that you get another piece, at least 3 pieces here, but not a 4th piece. So we're gonna draw those pieces out here just so that we can see them. So there's our second piece, and here's our third piece, and we can see that it's too much to do another piece there. I'm gonna put it in there anyways. There's that other piece, but it's too much. So we're gonna split this and see what fraction of this 4th piece we get there. And we can actually see it splits really nicely into 4 pieces, of which 3 gives us the fraction we need. So this is 3 3/4, or we can show that that is in fact 15/4, which confirms what we got using the algorithm. All right, let's try this with a smaller fraction divided by a larger fraction and see if we get the same sort of thing. So if we are using the algorithm, this is 2/3 times 4/5. And if we use our fraction multiplication, this should get us to 8/15 when we actually do the division. So we're asking ourselves, how many of these pieces fit into here? So you can see right away that it's not even a whole piece. We're gonna still highlight this as the piece that we're trying to fit into the 2/3. We're gonna get rid of the fractions here. We're going to split this so that we can break this whole piece up into enough to see what proportion fits into here. So let's start splitting this up until we see, and we can actually see it splits up really nicely here. Now, if we look, and this is why we take this off, this is sort of where it can be confusing if we leave the fractions visible. This says it's broken into 1/12. And although that's 1/12, those are 12ths of the whole, this is not a whole that we're talking about. This is the whole that we're talking about. And in fact, because we're breaking up into pieces, there are actually 15 pieces here. So this is our piece that we're breaking up, and we're breaking it up into 15 pieces. And you can see that there are 8 of them that fit into the 2/3. And so 8/15 fits in of our original piece fit into our 2/3, and that confirms what the algorithm showed us, that the answer was 8/15. So it's quite complicated to sort of verify what the division algorithm is doing, but it is definitely possible to visually connect that multiplication of the inverse to our division question.